Hello everyone and welcome to this tutorial where we're gonna have a look at deep learning functionalities implemented in eCognition. We're gonna try to do a land cover classification using CNN. CNN stands for Convolutional Neural Network, so that is deep learning. Why are we doing this? Because a lot of people have requested this. They want to do land cover classifications using CNNs, and here we go. So what will you learn? First of all, we're going to create a workspace with multiple projects. Then we're going to write a rule set that creates labeled sample patches based on a ground truth shapefile. Afterwards, create a rule set that creates, trains, saves, and loads a model. And finally, create a rule set that applies the model and uses OBIA methodology to create high quality land cover classification. I'm also going to mention a few best practices that we do recommend. We are not following this 100% in this tutorial, but I'm going to mention it and you can do a better job when you implement your project in eCognition. This is the basic workflow, starting with data labeling. So you need to have some objects or vectors that represent the classes or the features that you want to extract. Based on this, you can create samples. So we're going to create a sample space. We're going to generate knowledge. So we're going to create a model, train the model, apply knowledge. We're going to apply the model, and then you can do an accuracy assessment. We will train and apply on two different subsets of a scene. We do highly recommend, actually, if you create labels and samples, do it across multiple scenes so you have a certain variation in your samples. So what we recommend is, for labeling, you can use the manual editing tools in eCognition to draw points, lines, or polygons that represent the classes you want to create samples for. We also recommend that you do not evade difficult, unclear, blurry border regions of the classes that you want to classify, for example, forest. Otherwise, your network will only learn the easy targets, and that will give you disappointing results. We also recommend that you invest significant time in labeling initially, even before the first try, because the samples are highly important for deep learning. We're gonna have two subsets. In this top subset, we're gonna create samples. We're gonna load a vector that's holding information, the ground truth information of our classes. I'm gonna create sample patches, train the model, and save the model. Also gonna create the model, of course. And in the second subset, we're gonna apply the model and then rework those image objects and the result of the classification, the result of these deep learning algorithms. The result of the CNN is simply a heat map for each class that you want to detect, right? So you get values between 0 and 1, simply a heat map. You don't have segments or vectors, and that's what we're going to do in the second part in subset 2, where we apply the model. We're also gonna then apply object-based image analysis methodologies to create a nice land cover classification. And we're gonna do validation as well on the second subset. The accuracy assessment gonna be an accuracy assessment of the final classification compared to validation data that I have. You also can run an accuracy assessment of the model itself, which makes sense, but in this case I'm going to try to keep it as simple as possible, showing you really the most important algorithms that you will need to implement a meaningful deep learning workflow in eCognition for land cover classification. Okay, so let's open eCognition. I'm gonna create a new workspace, gonna save it in the folder where I have my data. You can save it wherever you want. I'm gonna give it a good name. Gonna call it CNN land cover classification. That's what we want to do. We want to use CNN to create a land cover classification. Hit OK. Now we have our workspace, it's empty. I'm simply going to use drag and drop of one TIFF file that we have for training and a shapefile. So if you go to the data folder, you're going to find this train TIFF. I'm simply going to use drag and drop, and that will automatically create a project here with the name of the TIFF file. We also need the shapefile train ground truth train SHP. Simply drag and drop the SHP also into the project. And you're gonna see here in the view settings that we've populated our project with 4 layers and 1 thematic layer. So 4 image layers and 1 thematic layer. I'm gonna rename the image aliases so I know what is what. In our case, layer 1 is red, layer 2 is green, this is blue, this is near infrared. And the vector layer, I'm gonna call it ground truth. Okay, let me quickly check if that worked out nicely. Here you see the ground truth. So we have points for different classes probably across the whole image. I created those actually within eCognition. Didn't spend too much time. You should invest more time if you want to have good results. Again, samples are probably the most important parameter in a CNN, and you need a lot of them. This looks good. I'm simply gonna hit the save project button. That's gonna save the project in the workspace, and then we can start creating our samples. Please go to the next video, make sure you have the setup right, and then we're gonna create samples and start with deep learning tools.